Good day everyone, we are excited to present our project which is automated plant care using ultrasonic and soil moisture sensor. I am Catherine Lariba.
And I am Jamari Dugas.
We are Best Infotech 3F student major in programming. Our project addressed the challenge of maintaining optimal plant health, especially gardening enthusiasts and urban farmers.
Manual monitoring and watering can be inconsistent or time-consuming. Our automated plant care automates this task, ensuring the plant get the care they need efficiently.
Welcome. Today, I'll be explaining our automated plant care system. This project uses various sensors and components.
Let's go through each sensors and its role.
The first essential component is the soil moisture sensor. This sensor measures the moisture level in the soil. It sends an analog signal to Arduino, which determines if the soil is dry, moist, or wet. Next, we have the ultrasonic sensor. Used, it measures the water level in the reservoir. The sensor sends out the ultrasonic waves and measure, calculating the distance to the water surface, alerts the system and user when water levels are low. The soil moisture sensor. The analog output pin connect to analog A0 on the Arduino. In the ultrasonic sensor, the trigger pin is connected to digital pin 9 and the echo pin is connected to digital pin 8. Let's start the simulation. The system read the soil moisture level from soil moisture sensor. If the soil is dry, the servo motor turns 90 degrees, simulating water flow. And also the buzzer sound if the soil is dry. If the soil is moist, servo remains at 0 degree. If the soil is wet, and it will remain 0 degree and no watering occurs.
Water level monitoring. Depending on the level, the appropriate LED lights up and the LCD shows the water status. The green shows that the water reservoir is full. Orange lead indicates a medium water level. Red lights up when the water reservoir is low, and the buzzer sounds an alert. Now I explain the code behind the automated plant care. We start by including the necessary libraries. These libraries enable control for the servo motor and LCD display. LCD used to display system messages, soil value, or water level. We initialize the LCD display and the servo object. We define the pins where each component is connected. These variables are used to store sensor reading. In this code, we declare the measure of water level. In this code, function ensures the servo motor moves gradually to the target angle. If the servo moves for 90 degree and lead indicator is turned on to show that watering is happening. In the setup function, we initialize the LCD, turn on the backlight, and configure the pin modes. In the loop, the system constantly checks the soil moisture If the soil is dry, it activates the watering mechanism. If the soil is less than 100, it will display soil is dry and watering plant. Buzzer emits a short sound.
And activate the servo motor.
In this area, the soil moisture logic will happen. Convert pulse duration to distance in centimeter, updates the LCD and takes action. Using this, calculate distance to the water, which tell us the current water level. In the water level logic, if the distance is greater than water level flow, the LCD will display the low water level. Else if the distance is in between the water level low and the water level medium. And LCD print the median level and the orange lid will be turned on.
Else if the distance is less than the water level high, the LCD will display the water is full.
Automated plant care automates essential plant care tasks such as watering and monitoring soil moisture and water level. This project reduces individual intervention, promotes efficient water usage, and ensure plant health.
Is a valuable tool for busy individuals, urban farmers, and gardening enthusiasts, contributing to sustainable and smarter gardening practices.